Good morning, everyone. Today, inshallah, we are going to finalize lesson 8.4. We were done with 8.1, 8.2, and 8.3. And today, after we finish part 3, it means that we are done with chapter 8. And next week, we are going to start totally with a new chapter, which will be about acids and bases. Okay, so let us go and start with our ending part of chapter 8. In today's lesson, we are going first to recap some ideas of lesson 8.4, part 2. Then we are going to discuss the third type of intermolecular forces. We already discussed two earlier, and today we are going to discuss the third one. And we are going to I will solve with you two questions that you might face in any of your exams later. And then you have to do a task in Google Classroom. And please, today is the due date. Last time, I accepted some of you to send for me the homework late, or not the homework actually. It is a task that you should finish it within the class. Some of you submitted it late, and I accepted it. But this time, the due date is today. Please, 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 you have to submit it today because it is part of today's lesson. And then you have to do the plenary as usual at the end of the lesson. Okay, so the objective of today's lesson, explain the hydrogen bond, and we will consider it as intermolecular force, and we will solve the questions related to all the three intermolecular forces. As a starter, three questions will pop up after I read these questions. You have to answer them, and again, please make sure that the spelling is correct. Question number one of the forces, intra or inter, is stronger than the other one. Intra or inter. Question number two, noble gases form which type of intermolecular forces? Number three, what type of force is presented in the following figure? I'm talking about this one here. Between this molecule and this molecule, what type of force will be present here? Okay, now let us do a quick recapping in order to continue with hydrogen bond. Last time we said that forces are classified into intramolecular forces and intermolecular forces. The first difference and the main difference between them, that intramolecular forces, it is the force that we can find between atoms within a molecule. But intermolecular forces, it's actually between molecules, not between atoms, it's between molecules. Difference number two, intramolecular forces are stronger than intermolecular forces. Number three, examples of intramolecular forces, we have the covalent bond, the ionic bond, and the metallic. But when I say intermolecular forces, the examples are dispersion force, dipole-dipole force, and the hydrogen bond. And we said that these forces, all of them are weaker than any of these three. Another thing, we have to know that dispersion force, dipole-dipole force, and hydrogen bond, here we classified them from the weakest to strongest. So the dispersion force is the weakest among these three, or actually among all. Dispersion force is the weakest among all. So dispersion force is the weakest, then dipole-dipole force, then hydrogen bond is the strongest, and this one, it is the one that I will explain in details for today. Before I start with a new part of today's lesson, I want you only to remember that dispersion force and dipole-dipole force, we categorized them as van der Waals forces. Okay, let us go further. For hydrogen bonds, what I want you to know about hydrogen bond, that this hydrogen bond is a special type of the dipole-dipole interaction. Why it is a part of dipole-dipole interaction? Because hydrogen bond will form because of interaction, or actually because of attraction between two molecules. These two molecules again will have dipoles. And as we remember, dipoles, it means that the molecule itself has two opposite poles or two opposite sides of charges. One part of the molecule will be negatively charged, the other part of the molecule will be positively charged. Okay, let us go further. Okay, Miss, so what is the difference between hydrogen bond and dipole-dipole bond or dipole-dipole force? How can I see the difference between them? Okay, I will reach that part at let me say at the end of the lesson. You will know how to differentiate between dipole-dipole force and the hydrogen bond. Now, if you look at this picture, I already used this part or this figure in previous lesson in order to show you that the part which will have less number of electrons will always have a charge of positive delta, where the part which will have more electrons, it will have a negative delta. The positive delta of this molecule will be attracted to another molecule. The other molecule will have also negative and positive deltas. So again, we are repeating the idea of the dipole-dipole force. But what I want you to know that hydrogen bond cannot form between any two dipoles in molecules. Okay, miss. So where we will find hydrogen bond? Hydrogen bond will form only if we have three atoms. And I want you to mention these three atoms after I show you three examples. Each example or each slide that I will show you now, it will have one example. In each example, there is a special atom that will appear in front of you. The first example is the water. Here in front of you, you have water. This is oxygen, and these two are hydrogens. So if I have a water molecule with another water molecule, with another water molecule, here I have 5 water molecules. The attraction between each and every water molecule is called a hydrogen bond. The positive charge of the hydrogen atom of this molecule is attracted to the negative part of this molecule of water. So positive charge here, negative charge here, they will attract each other, they will form a hydrogen bond. Okay, next example. If I want to show you this example, here again I have water molecule, but it is bonded to this guy. Now what is the name of this molecule? This is called ammonia. Ammonia is N, then we have 3 hydrogens. The positive charge of water molecule is being attracted to the negative charge of the nitrogen. So here, in this is the second example. What is the other atom that appear in front of us, which is different than these atoms? Here I have oxygen, hydrogen, and hydrogen. Here I have oxygen, hydrogen, and hydrogen in water. But here I have nitrogen, hydrogen, hydrogen, and hydrogen. So what I want you to see and what I want you to recognize, that hydrogen in ammonia is not bonded with oxygen, but it is bonded to nitrogen. So here I have a new guest in our ideas. Okay, I will show you the third example in order to finalize the how we form hydrogen bond. The third example here, what do I have? I have H with F and I have H with F, hydrogen fluoride and hydrogen fluoride. Okay, the negative part of the hydrogen fluoride molecule on the right side is being attracted to the hydrogen, which is the opposite, the positive part of the molecule on the left side. So who's our guest in this slide? Our guest here is the fluorine atom. So what I want you to see that hydrogen bond can form if I have a hydrogen bond. It means that sure I should have a hydrogen, but this hydrogen should be bonded with oxygen or nitrogen or fluorine, and that's it. This is a hydrogen bond. So as a quick recap, hydrogen bond is the strongest intermolecular force among the three. Hydrogen bond can form only and only if we have hydrogen, but this hydrogen is bonded to nitrogen, oxygen, or fluorine. These are the only elements that can form a hydrogen bond. If you want to remember it easily, I always remember it as NOF, N-O and F. And please remember that electronegativity increases when we go to the right of the periodic table. Nitrogen is in group 15, oxygen is in group 16, fluorine is in group 17. So if hydrogen is bonded to nitrogen, it will form a strong hydrogen bond. But if hydrogen is bonded to oxygen, it will form a stronger hydrogen bond. And if hydrogen is bonded to fluorine, it will form the strongest hydrogen bond. Okay? Perfect. So let us go further. Now, some questions are important to solve when we talk about hydrogen bond. One of these questions is the following. Why are hydrogen bonds important? Why they are the strongest? Why they are important? Because hydrogen bonds are the strongest of intermolecular forces. They will always help us to determine the properties of water. They will tell us why water is liquid, why ammonia is gas, why water is liquid while another molecule is solid at room temperature. We can know this information only if we know the type of intermolecular forces between these molecules. So, knowing molecules as gases, liquids, and solid, it will be done if we understand and if we know what type of intermolecular attraction do we have. Now, a question that you might face. Question number 1. Explain why ethyl alcohol has a higher boiling point than methyl alcohol. Okay, miss, how can I solve this question? First of all, you have to think about ethyl alcohol. What type of bond we can see in ethyl alcohol? You will say, I have carbon and hydrogen, so we might have dispersion force, but I have O and H. So because I have this type of bond, it means that this OH will form a hydrogen bond. Here also, I have methyl alcohol. Methyl alcohol also has OH, so it will again form a hydrogen bond. So both of them will form a hydrogen bond. So both of them will have strong attraction. So both of them will have high boiling point. But why this one has higher boiling point than this one? You will say both of them have a hydrogen bond which is strong, but this one, ethyl alcohol, has more carbon atoms and more hydrogen atoms, which will make ethyl alcohol heavier. It has higher mass than methyl alcohol. So both of them have the same intermolecular force, which is hydrogen bond, but ethyl alcohol will have higher molecular mass, which will make the boiling point higher.